Hi everyone, and good afternoon. Welcome to our Geospatial Commission Science and Innovation parallel event for the KTN Space Geospatial Virtual Pavilion for COP26. For those who don't know me, I'm Olivia Powell, also known as Olive Powell. I'm the international leader here at the Geospatial Commission, and I'm delighted to be chairing today's session. So climate change is one of the, if not the most biggest challenge basically in the world we're facing right now. And it is our responsibility to put together and bring forward every possible solution. And so today the Geospatial Commission is very proud to showcase some solutions that our partner bodies can provide. And they'll go through real life example that can be applied across the UK and abroad. What we aim to demonstrate today is the breadth of opportunities that there is in the innovation use of geospatial data to help towards net zero and building a more sustainable society and future. So I'll just go through quickly the plan of today's session before I hand over to our speakers. So first, I'll let Talia Baldwin, our director here at the Geospatial Commission, who will introduce the session. Then we'll be traveling around the world, hearing from our 4 partner bodies cases and projects for about an hour. So we'll first hear about Juliet from Ordnance Survey, then James from the UK Hydrographic Office, Mike and Jerry from the British Geological Survey, and last but not least, Gareth from the Coal Authority. I'll introduce them a little bit better later. At the end, after their presentation, we'll then have the opportunity to have about 30 minutes for speakers' questions in the panel session. And so I will remind you all to use the question tool in the platform to be able to type your questions so we can bring them forward to the speakers. So we hope you get inspired and get some great ideas on how you can use and access geospatial data to make a difference, whether locally, regionally, or globally. And without further ado, I'll hand over to Talia. Over to you, Talia.
Thanks very much, Olive. And hello, everybody. It's a great pleasure to welcome you all to today's session, showcasing some of the excellent and innovative projects being undertaken by our key UK geospatial agencies, together with international partners. I am Talia Baldwin. I'm director of the Geospatial Commission, which is the UK policy lead for location data, and for the purposes of this event, a partner of the Space and Geospatial COP26 Virtual Pavilion. We are very grateful to the Knowledge Transfer Network for pulling together so many exciting and informative speakers and events over the last 2 weeks. Over the next couple of hours, as Olive says, you'll hear about some specific projects that are applying location data intelligence to tackle some climate change challenges. Before that, I wanted to just take a brief amount of time to provide some context for why location data is so important for understanding and then addressing climate change and our response to it as a global community. The impacts and solutions to climate change do not stop at borders. So neither must our need to collaborate in applying the insights that location data can provide. Location data helps us to function as a society more effectively, from efficient delivery of public services that respond to population density and needs in geographic areas, to opportunities to spend our time on the things we choose to do rather than being stuck in traffic or waiting in for a delivery. And location data is and will continue to be crucial for understanding and solving some of our biggest societal challenges. As part of this, it is already underpinning many climate change mitigations and adaptation solutions, including the pursuit of COP's 4 key goals: securing net zero by 2050, adapting to protect communities and habitats, mobilising climate finance, and working together. Where questions are at the heart of identifying and then making the right decisions today around adaptation and resilience. Arguably, it has been another event, albeit with a much more immediate, though potentially long-lasting impact, that has elevated the value of location data in the eyes of key decision makers and governments globally. I think we've all seen how the COVID pandemic has brought the benefits of the application of good location data into sharp focus, providing us with a capability to monitor and model the spread of the disease and use data innovations to support real-time attribution analysis. Before this, there was arguably a wider preconception that location data is a subset of data, that it is a niche subject area, that it relates to a specific sector. Now we can see, however, quite literally through some of the data visualizations that it helps enable, how location data is the glue that brings together various data sets. Access to location data provides us with an underlying capability that gathers in value and usefulness the more that data is linked. The insights that we glean can be pointed at solutions to improve society. It is no surprise then that this realization and advancing capability can be applied in the climate action context. And in the Geospatial Commission, we are keen to promote the whole of the climate-related collaborative opportunities afforded by location data. The UK is a very active participant in the UN's geospatial community. This community doesn't need to be persuaded about the value of location data. We can easily see its relevance to at least 14 out of the 17 Sustainable Development Goals. In the Geospatial Commission, we prioritise partnership working, both within and outside of the UK. The UK Geospatial Strategy aims to articulate the benefits of location data and set a blueprint, a map for targeted initiatives that sit under our 4 missions. Our first mission is about promoting and safeguarding location data by building public trust and confidence in its use. For example, we are engaging with the public at the moment in a dialogue about location data and ethics to understand what people know and how they feel about use of their location data. Our second mission is about enabling access by evidencing then delivering targeted data improvements using clear methodologies such as the FAIR principles and learning from international frameworks such as the Integrated Geospatial Information Framework. As part of this, we are leading the development of a single digital platform in the UK that contains information about the location of buried assets. And we are working with multiple of the partners across the UK to improve data about what our land is used for. Mission 3 for us is about improving skills, capabilities, and raising awareness of the value of location data. We work hard at simplifying the message, demonstrating as tangibly as possible what better location data can provide, and understanding how we all need to improve our skills to harness the benefits. Our fourth mission is about driving innovation so that we are at the forefront of the global opportunities that have arisen from the developing digital and data economy. Through our strategy, we aim to work with citizens and businesses to deliver a sustainable, climate-friendly society. The opportunity to deliver a session like today's helps broaden our audience through demonstrating real-life examples of how location data can directly support climate action solutions. So today's programme shows the versatility of applications of location data and addressing climate change and working towards a sustainable future. The projects on show are led by the very best geospatial agencies in the UK, the Ordnance Survey, the UK Hydrographic Office, the British Geological Survey and the Coal Authority. These projects demonstrate the extent of the UK's geospatial capability, the breadth and diversity of the way geospatial data can be applied and used, and very importantly, how collaboration drives improvements and more innovative solutions. We think that this type of collaborative problem solving and innovative thinking needs to be harvested to help achieve COP26 goals. And we therefore hope that this showcase is of relevance to our peers in other countries. To our viewers overseas, we would love to hear from you, understand your perspectives, your experiences, and work together to improve our approach. In the UK, we nurture a culture of collaboration. We like finding common goals and aligning our approach to new goals. Today's showcase demonstrates the huge benefits of collaboration between agencies, sectors, and countries, which echoes the spirit of COP26 for climate activities. In summary, it's increasingly clear that location data is fundamental to climate action. It's our challenge as a geospatial community to demonstrate its value to the cause. Only then can we be empowered to make informed and timely decisions that bring together the right data so that we can identify, refine, agree, and deliver to our common goals. Olive, back over to you.
Thanks, Talia, for such inspiring introductory words. So without further ado, I will present our first speaker and a first showcase. So Juliette Ezeki. And Juliette has over 30 years experience working for many global companies such as Racal, Leica, Thales, as we say in French. I'm not sure how you say it in English, in surveying and engineering roles, and including running her own business actually for Geoservices in Nigeria for 10 years. So in her talk, Juliette is now the head of International Ordnance Survey, and in her talk, she's going to take us to Lusaka in Zambia, where Ordnance Survey used aerial imagery and AI to automate and produce very quickly a base map of informal settlements. So over to you, Juliet.
Thank you very much, Olive, for the introduction. And thank you everyone for joining us, wherever you are joining us from today. Ordnance Survey is the national mapping agency of Great Britain and a government company. Informal settlements make up over 54% of the urban population in Africa, with profound consequences in terms of health and well-being, prosperity, environmental impact, plus the fact that retrofitting infrastructure ends up being 3 times more expensive. In many African cities, an urbanization plan is needed to better target investment in critical infrastructure and services, upgrading informal settlements and adapting to climate change challenges. But how do policymakers make informed decisions and quickly? This session will demonstrate how innovative location data techniques can gain vital information in a fast and efficient manner to deliver city and national level challenges. Born out of the survey of the built environment professions and in support for the call on action on sustainable urbanization in the Commonwealth, it's a transdisciplinary collaboration brought together by the Commonwealth Association of Architects in collaboration with the International Growth Centre, Ordnance Survey and the Nesta Challenge to tackle informal settlements, starting with Lusaka in Zambia. So working together, the organizations produced detailed data in a few weeks so that policymakers could start to ensure a more resilient urban future for Lusaka. What could be repeatable, which can be repeatable even, in other growing cities to solve the policy problems local and national governments in Africa face. My slide where will not move. Here we go. So location data and services are critical to adaptation and socioeconomic success. High quality, fundamental and authoritative data is relied on by government, society and industry. Having an accurate and current understanding of the geography means you can better predict for a crisis as well as plan for a crisis and improve your response to it, saving lives. Detailed mapping data is the foundation for secure land rights. Secure land leads to better education, attracts inward investment and increases taxation revenue. Artificial intelligence and machine learning using the latest technology processes means you can benefit from organizational efficiency and cost savings, avoidance of utility strikes and damage to utility assets through readily accessible information, improving access to the digital asset records in one view. Accurate mapping provides the foundation for the geoservices industry, which contributes, believe it or not, to 1 to 2% of the GDP. Geospatial information is essential for measuring and monitoring progress against the UN Sustainable Development Goals. Urbanization as part of Sustainable Development Goals from a UN statement has stated that 67% of the world's population will live in cities by 2050. That's increasing from 55% today. 90% of the increase will come in Asia and Africa alone. So why do we need to act now? Why now? It's predicted that nearly 50% of the projected 2.5 billion increase in the world's urban population will be in Commonwealth countries. 65% of the targets for the United Nations Sustainable Development Goals are linked to territorial and urban development. Currently, over 54% of the urban population in sub-Saharan Africa live in informal settlements. Cities need detailed, trusted, high-quality, disaggregated data to plan and manage expansion and climate change challenges efficiently. A collaboration, because as Talia has said, and Olive has also told us about this, a collaboration between Ordnance Survey, the IGC and the CAA was formed to respond to the issue of insufficient location data by piloting the creation of an automated base map of Lusaka. The partnership focused on the identification of informal settlements and at speed, working together with the Zambian Ministry of Local Government and the Ministry of Lands and Natural Resources. These 5 organizations worked together to deliver a detailed map of Lusaka that could be relied upon to make policy decisions. So Using aerial imagery and cutting-edge automation techniques, Ordnance Survey created a base map of Lusaka, faster and more resource efficiently than ever before. Using our automated approach, 420 square kilometers of detailed base map was created in just 10% of time compared to manual processes. The map created by Ordnance Survey provides data to enable the government to identify and locate settlements, confirm the size of the settlements and the number of built structures, confirm how formal and informal neighborhoods are served by roads and public spaces, assess the density of population based upon the number of buildings, provide a prediction of informal settlement growth, their potential capacity and extents. So, I know you're probably wondering what you're looking at, but this is the basic imagery that we used. And what our computers did was trace and create the map features from this original imagery. Over 420 square kilometers of highly detailed mapping was delivered in 1/10 of the time when compared to traditional techniques. The things that are appearing on the screen now are more than 300,000 buildings were captured. And the beauty of this was that our computer was able to differentiate between buildings that were also under construction, which are the pink buildings that have now appeared. 74 square kilometers of trees were also captured. And more than 4,000 kilometers of road networks were also picked up. And it was interesting to know that our data was able to locate and pick up sealed and unsealed roads, so the dirt roads were also picked up. From our mapping, we were able to deduce the informal settlements population of Lusaka had reached an incredible 1.4 million, which was 70% of Lusaka's population. We were utilizing data that was generated from a residential analysis from the University of New York. This data and the mapping that we've derived is now available to the government of Lusaka via their National Spatial Data Infrastructure Data Hub, which is what we're looking at here. The data is being used by the Zambian government and is available to all government departments. The geospatial data is now utilized to help inform all sorts of things and plan for critical infrastructure. It's helping policymakers to decide where to put public services, sanitation, healthcare, etc., in addition to helping with the response to pandemics and, of course, recently locating vaccination centers. This was a very exciting project, and I hope you've enjoyed your tour of Lusaka and have seen a bit of Zambia. Finally, I'd like to let you know about our other latest reports in our series that are released in our reports on sustainability and urbanization. With these, we cover other examples from across the globe of how nations have managed urbanization and sustainability and set in motion a cascade of benefits for the urban poor, lifting them out of poverty, stimulating economic growth, as well as examples of building resilient cities and boosting citizens' health and happiness. Thank you for listening. Please feel free to reach out to myself and our other partners about the things that we've raised today. We're always actively looking for other African cities to partner with to demonstrate how detailed geospatial information can help and manage urbanization. So please contact me. My details are on the screen now. Thank you very much, and back to you, Olive.
Wow, thank you, Juliet. That was a great project. I love the fact that tools like machine learning can help provide that foundational spatial data that actually can help not only with climate mitigation, like you said, about understanding sustainable land management, but also with those climate adaptation strategies and also responding to emergency situations, like in the case of climate change. So as you say, time is now climate change, time is the essence, and having those really critically fast-paced solutions is really important.
Absolutely.
So remember, the audience out there, if you've got any question for Juliet, please do use the question tool on your platform so we can ask Juliet later on. So I'll move on to introducing our next speaker, James Carey. So James is the head of operational delivery at UKHO, where he's responsible for Hydrographic Office, obviously, where he's responsible for implementing the marine spatial data infrastructure. He's also the lead on humanitarian and disaster response and COP26, so definitely the right person to be here today. James is going to talk to us about the project Seabed 2030, which is about building a comprehensive seabed map and why it's so important to improve its coverage and quality, as marine data is, again, a fundamental data set to climate change modeling, and adaptation. So over to you, James, the floor is yours.
Thank you, Olive. Hopefully you can see my slides there. So yes, I'm James Carey, from the UK Hydrographic Office, where for 226 years we've been mapping the world's oceans. Thank you for having me today, and I'm going to talk about the state of ocean mapping and what the international community are doing about it through something called the Seabed 2030 initiative, and how here at the UK Hydrographic Office we're supporting that. So collectively, there's a level of blindness when it comes to understanding the sea and its contribution to understanding and adapting to climate change. Whilst the sea is home to some of the biggest carbon reservoirs on the planet in terms of seagrass, kelp beds, we don't hear as much about its role in climate change as we would about rainforests. Even though seagrass, for example, absorbs carbon 35 times faster than rainforest does. This is understandable. If you look at this picture of the globe, this is what we tend to think about when we think about planet Earth. However, if we look at it from directly the other direction, the Pacific is massive. The sea is big. If we turned the Earth 180 degrees, this is what you'd see. It should probably not be called planet Earth. Some people say it should be called planet ocean. It covers 2/3 of the Earth's surface, and if you use the well-known unit of measure that is an area the size of Wales, you could fit Wales about 17,500 times into the ocean. The United States would fit into the Pacific Ocean about 16 times without the edges touching. So it's massive and it's deep, on average about 3,600 meters deep. At its deepest, it's just under 11,000 meters. So if you took the Eiffel Tower and stacked it 33 times in that depth, the top would still not be touching the surface. And it's incredibly dynamic. It has its own climate, it's tidal, it's moving around. So data collect that you undertake often has to be done more than once. It's often said that we know more about the surface of the moon than the deepest parts of the ocean. Well, it's quite different challenges. I took this photo using my camera phone in my back garden. I'm going to talk a bit later on about what we can do using remote sensing, but if you want to gather similar sorts of data for the ocean, you actually have to go there and gather it directly using very specialized equipment. So how do we build a picture of the ocean, the seabed, with that in mind? So the Seabed 2030 project is an endorsed UN Decade of the Ocean science activity between the Nippon Foundation and GEBCO, which is an IHO and IOC collaboration, with the aim of properly mapping 100% of the oceans by 2030. So if we try and build that picture, it might look something like this. Needless to say, these are not my hands doing the work. So every blue or green block on this picture represents survey data that's available through Seabed 2030. And it's easy to have a look at this image, zoom in, and think that doesn't look so bad, because actually our eyes are drawn to the areas where data exists. What you're seeing is actually almost a dot-to-dot puzzle. And what you don't tend to see is all of the areas where the black is, which is where data does not exist. And so by putting this model together in this way, what I'm able to do is show you this picture. So in a digital world of ones and zeros, these are the zeros. This is the data that doesn't exist. This is 5,000 pieces of Lego we didn't use when we were populating that map. And so effectively, that's ignorance. That's stuff we don't know. And as has been said a few times in the last 2 weeks, what gets measured gets managed. So what can we do about that? Well, we can use remote sensing to start filling in some of the gaps. So satellite-derived bathymetry, going out to space appropriately enough for this conversation. This can get down to about 20 meters in clear water. So where the water is particularly shallow and bright versus where it's very deep and dark. There is a certain level of validation you need to undertake when you use this technique. So kelp beds can show up as dark, but they're shallow. So it's not flawless. You can use a very similar technique more locally. LiDAR can be mounted on a plane or a drone, and you can get a similar result down to about 40 meters. So you can actually get quite a lot of stuff in the coastal areas using those remote sensing techniques. But if you want to apply those globally, what you hopefully can't see very easily on this display, all these yellow areas are where those techniques would work. So they're very difficult to see because actually on a global basis, they're actually quite small. Where you've got the light blue areas on this display, that's where you might be able to use fairly standard multi-beam echo sounder in to get the same modern surveys. And so there's very dark blue water where it's very deep and you need incredibly specialized equipment. What we can do also with remote sensing is we can start to generate automatic coastline. So what this does is this takes techniques developed by a immensely talented team of data scientists and data engineers here at the UKHO, and they can take imagery and they can use that, they can anticipate the tides, and they can actually generate a coastline. And coastline actually, from a climate change point of view, is very important. One of the things that it allows you to do if you can generate a coastline is also calculate your marine limits and boundaries. That's important for a whole host of reasons. If we want to support the aim to protect 30% of the world's marine areas by 2030, the 30 by 30 project, you need to have good generated coastline in order to do that. And what that allows nations to do is to manage and protect their marine environment. What we can also do using the same techniques is we can start to identify what sort of coastline we're looking at. So mangroves are massively important when it comes to climate change. We can use them, they're a carbon sink, they help mitigate the damage caused by storm surges. And so monitoring of mangroves and understanding what's happening to mangroves is really important. And what we've managed to do with our machine learning and data science techniques is actually start to use that imagery to automatically identify where mangroves are. And if you look at the right-hand image here, that's not a photo, that's actually that automatically generated image imported into a digital twin. So we can actually use it to start understanding areas of the world in more detail. In this case, Belize. Similar applications of a technique, so we can use it to identify where offshore energy infrastructure is in place. So it's not well understood, but actually a lot of oil platforms and oil fields, wind turbines, that sort of thing, they're not that well mapped. The information doesn't exist. So we can monitor and we can map those by using synthetic aperture radar imagery. And what that is good for is it can see through cloud, it can see hard metal type objects on the surface of the sea, but again, it doesn't penetrate into the sea. So if you do want to actually get good quality survey information in the marine environment, you do have to go to where you want that information, and you have to do the equivalent of mowing the lawn. You have to do stripes up and down. So extremely labor intensive. It requires specialist skills. It requires some big vessels that chug a lot of diesel. So, and actually for the very deep areas, the sort of capability we're talking about, it's incredibly rare. So with that in mind, the UKHO has been undertaking seabed mapping programs. We talk about small island developing states. They prefer to be called big ocean developing states with good reason. The island of Kiribati has a marine area that's the equivalent of Brazil's, even though it's actually got only a few hundred kilometers of actual land. And with these countries, we've been going out, we've been doing surveys, and we've been building our picture of those areas in that way. And again, back to the theme of collaboration, this isn't a solution that's going to be solved by getting on a plane and flying to every place in the world to map it. This is something where we need people to have skills in the countries that are affected. And so we've been undertaking survey training in places, in this case, Jamaica and Guyana, and also training in hydrographic governance and awareness of marine spatial data infrastructures. Another technological solution, autonomous vehicles, potentially more environmentally friendly than the big diesel chugging vessels that we traditionally use. And also they have the capability, we can have a lot of them in one place. We can actually use them for longer periods of time, so they can go out and stay in place for quite a long period, sort of fairly passively collecting data. And we can actually get some quite rich data as well. In the bottom left corner, you get some information there from remote operated vehicles equipped with cameras, which can go in and investigate such things as shipwrecks. So lots of technological and collaborative solutions there for us to get more data. What happens then is we need to find a way to process that data so that it's actually usable. With the aim in mind of making this findable, accessible, interoperable and reusable. If you look at the left-hand picture on here, there's a lot of noise that gets collected in survey data. And it's quite a skilled job normally to clean that up. So the more data we get, the more work is required to process the data and make it useful so that it looks like what's in the right-hand window. At the UKHO, again, our team of data scientists, data engineers, working with our surveyors and our data management experts, they've been working on this problem and they've created a generalized additive model for something we call the bathymetry data noise cleaning capability. And what that allows us to do is it actually allows us to halve some of the processing time for some of these data types. And so when you think that actually between all the technological solutions, the collaborative solutions, CBER 2030, we're hoping to get enough data to map the whole of the oceans between now and 2030. This is really important. And with that in mind, we've recently signed a three-way memorandum of understanding between ourselves, the CBER 2030 programme, and Teledyne Carey, who make survey processing and cleaning software. And what that allows us to do is provide this algorithm and this technique to CBER 2030, so they're better able to undertake cleaning and providing of the data that has been given to them through that programme. So what we hope is that by 2030, next time you come to look at this map in 10 years' time, it will be complete. I've included a web address there if you want to find out a bit more about what we've been doing in some of these techniques and what we've been contributing towards COP26 in terms of talking about climate change and the oceans. And hopefully that's generated some interest and some questions for later on in the programme. So thank you for having me, and back to you, Olive.
Thank you, James. Fascinating. I'm always, well, as a Lego fan, I do love the Lego analogy. It puts it back into perspective, actually. And as you say, you know, how crucial ocean data is important for, or how crucial it is for climate action, but actually seeing how ambitious your project is in terms of, you know, covering the 80% of unknown seabed within the next 8 years is quite a challenge, and how you use all these different tools and technology to achieve that, and collaboration and capability. So this is really exciting. And I do hope that a lot of people in the audience will put some questions in for you. Okay, so I'll without further ado, thank you again, James. I'll move on to our next speakers, our tandem presenters, Mike Spence and Jerry Wildman, who are talking about the UK Geoenergy Observatories. So the UK Geoenergy Observatories are new and world-class field research facilities being developed by the British Geological Survey at a scale, as a scale test site for the development and optimization of subsurface thermal energy technologies. Scientists and engineers working at the observatories will generate a wealth of data over the next 15 years operational lifetime. And the presentation does provide an introduction to the various eco-geosites and an overview about how that data can be managed to maximize its value and accessibility. So Mike, who's going to be speaking first, I believe, is the Director of Science for the UK Geoenergy Observatories, and Jerry is the BGS Data Delivery Lead, representing the UK Geos Informatics team. So the floor is yours, Mike and Jerry.
Thanks very much, Olive, for a great introduction, and good afternoon, everybody. So, yes, I'm Mike Spence, and I'm presenting with Jerry Wildman today on the UK Geoeng Observatories. These are brand new, at-scale underground observatories supporting the energy transition. Now, we heard from Talia at the start of the session about the importance of geospatial data for all aspects of net zero. And I'm here to tell you about these facilities, which are going to generate a very particular kind of geospatial data to help deliver net zero. And that's the data that we can get from the subsurface, from the rocks and the water beneath our feet. Now, one of the key goals for decarbonisation of energy is the transition of heating and cooling of buildings to renewable energy sources. So there's a lot of work being done on this, a lot of data gathered already. And we know that buildings are responsible for about 30% of UK national emissions of CO2. And the vast majority of these emissions result from heating. And together, the building emissions from heating account for about 23% of all UK emissions. So that's a major target to aim for in terms of decarbonisation. And on a global level, the IPCC report from 2010 estimates 32 to 34% of global final energy consumption is used for space heating. So there's a tremendous opportunity here. And the Geoeng Observatories are research facilities that BGS are developing with NERC and UKRI with funding from BEIS to develop the subsurface research infrastructure that we can use to really understand the sustainability, the upscaling and the environmental impacts of these exciting new thermal technologies. So what are the Geoeng Observatories about? Well, the starting point in this is that the subsurface can store a lot of thermal energy. The Earth is very large. There's a lot of ground beneath our feet. And just by way of example, a cubic meter of saturated sandstone bedrock would release about 3 megajoules of energy for every degree C and temperature change that you put it through. What can you do with 3 megajoules of energy? Well, it's sufficient to raise about 8 litres of water from room temperature to boiling point. So there's a tremendous reserve of heat there. And, you may say, well, that's, it's not heat that we can use, but you can, because heat pumps, which are an established technology, can be used to extract that energy and amplify it for use in the heating of buildings. And on the right-hand side of this slide here, there's a simple illustration of that. So in the shallow subsurface, we've got low temperature, high volume heat, a lot of low temperature rock. If you can circulate a fluid through that, you can extract the heat, put it through a heat pump, works like a fridge in reverse, that amplifies the thermal energy, and you can put that into a building. And this is an established technology. There are lots of these systems being installed worldwide. But the thing is, we need to increase the rate of this tremendously and also increase the coverage of it. So a target's been set in the UK for a 20-fold increase. So from around 30,000 installations of heat pumps per year up to 600,000 heat pumps. Now, heat pumps can extract energy from the air as well as the ground, but the ground is a tremendous resource that is not utilised to any large extent at the moment. And so if we can effectively tap into that thermal energy that's in the subsurface, then there's a tremendous opportunity here to decarbonise heating of buildings. So coming on to the Geoeng Observatories, what are they about? Well, there are 3 Geoeng Observatories. One of them already exists. And Gareth, who will be speaking after myself and Jerry, knows a lot about this. This is the Cardiff Observatory, and it's about urban thermal mapping. Now, if you're going to extract heat and use it to heat buildings, then you need to understand what the distribution of temperature is in the ground. And BGS has worked with the Cardiff City Council to instrument a large network of boreholes under Cardiff City, and temperature mapping has been undertaken to profile the heat energy distribution and the accessibility of that heat, how easy it is to extract it. So that's one existing facility that's part of the family of Geoeng Observatories. The second observatory I'm going to tell you about is the Cheshire Observatory. Now, this is a slightly different type of ground thermal energy. This is aquifer thermal energy. The Cheshire Observatory is in the design stage at the moment, but it's going to be a network of sensor boreholes and pumping wells installed in an important regional sandstone aquifer in Cheshire. Scientists and engineers will be able to come to the Cheshire Observatory and investigate how the rock properties, the borehole design, groundwater flow influence heat transfer and storage to and from the heat exchangers that transfer the energy to the surface. And it would allow us to answer questions like what's the effect of long-term temperature change on groundwater quality? Does it affect the microbiology? How can we design the heat extraction systems to maximize the thermal transfer from the ground and minimize the development costs? And then the third observatory that we're going to talk about today is the Glasgow Observatory. Now this one is drilled, the boreholes are in the ground, and we're preparing to install the above ground infrastructure which will actually extract the heat. The Glasgow Observatory is a network of pumping wells and sensor systems that have been installed in former flooded coal workings close to the COP26 venue, just outside the city centre in Glasgow. And scientists and engineers will be able to use the Glasgow Observatory to circulate water through the old mine workings. As you go deeper down into the ground, the water in the mine workings gets warmer, and the important questions such as how should you circulate the water to extract the heat most efficiently? What's the effect of circulating the water on the mine workings themselves and on the quality of the water in the mine workings? And all that information is very important for development of effective monitoring systems, policy and regulation. Now, I'm going to talk a little bit more about the Glasgow Observatory towards the end of this presentation. Just to say before I hand over to Jerry, the resource there's a tremendous resource from mine water geothermal, and Gareth will talk about this in the next presentation. And this just illustrates the distribution of the coal mine workings, the former coal mine workings across central Scotland. And you can see that, as you might expect from the history of the Industrial Revolution, the large urban centres in the central belt of Scotland generally coincide with these former coal fields. So these passageways, these galleries filled with water, they're there. They underlie large areas of the urban areas in central belt, and so if we can possibly exploit this thermal resource, then we can really take advantage of that for decarbonisation and net zero. Okay, so that was an introduction to the UK Geoeng Observatories. And I think you can see that we're going to be generating a lot of different data of different types from the observatories. We're going to be operating them for about 15 years. And it's really important that we do a good job on communicating that data, modeling the data, making it available to the worldwide research community so they can use it to best advantage. Yes, so at this point, I'm going to hand over to Jerry Wildman. I'm just going to jump out of the seat and let Jerry take on. So there you go. Thanks, Jerry.
Wonderful. All right. Thanks very much, Mike. So before we get too further down the line, let me just explain a little bit about some of the data that we're collecting under the Geoeng Observatories programme. As you can imagine, knowing what's happening under the ground is quite a difficult thing to capture. So planning our data collection has been incredibly important to make sure we can gather as much information about the subsurface as possible. So there's some examples on this slide about the sort of information that we're gathering. So as we drill a borehole, we'll extract the rock out that borehole and we'll image it in high resolution format. And that you can see that is the main image on the slide. We've also got a series of seismic arrays that have laid out across the sites, and they're monitoring microscopic ground movement and ground motion. And we're also putting probes and instruments down the boreholes and measuring the temperature and the pressure and the chemistry at depth. So collecting the data is really important, but sharing the data is probably even, well, is just as important as that. And like many in the data community, and it's been mentioned a couple of times already in this session today, is we're looking at how we can make that data fair. So we're looking at how we can make the data findable, accessible, interoperable and reusable. And we're doing this in a number of different ways. So to start with, we're looking at licensing and how we share the data legally. Wherever possible, we're using the open government license to share that information. So it's being shared under an open license. The standards that we're using to share our information and our data are also very accessible. We're using the Gemini standard for our metadata, and we're looking at various number of standards for our API delivery. We're looking to release the information and data as quickly as we possibly can. So we've got a great digital science lab platform, which I'll give you a short demo of in a moment. And we're releasing information on that really quickly, given early access to allow people to feed back and tell us what's working and what's not working. Importantly, we're also looking to develop, or we've also adopted a user-first approach to the design, using user experience, tools and techniques, and very much developing a co-designed service. This is really, really important to the project, the user-focused co-design. And this is where collaboration really is key. You know, we've had a number of different focus groups, we've been at public consultations and debates, and we've really encouraged some really positive and negative feedback on the platform that we're generating. The squiggle there is supposed to demonstrate the build, the design and the build process. And you can see at the start of the squiggle, there's a lot of activity. And this represents quite a lot of the discussions that we had. And it's quite iterative, it's quite messy, it's quite untidy, but that's okay. In fact, that's sort of intentional, because what we want to do is iron out a lot of these questions about the platform as early in the process as we possibly can. So by the time we get into the build phase, we know exactly what we do, and we're clear on what the thing needs to look like, and it all comes together quite quickly and quite efficiently. So the platform itself, so I promised a demo, so I'll just give you a short run through of what the platform looks like. This is the Digital Science Lab, and it's on the UK GEOS website, and we'll share the link at the end of our presentation. As I say, it's been co-designed. We have a social media wall on it that contains all of the latest tweets, videos and blog posts. So we're sharing our news and information in one place as quickly as we can. We have a UK GEOS data catalogue where we're storing all of the information and the data that we're collecting. And this has been designed in the GeoNetwork platform, and it's using Gemini compliant metadata. And if we just have a look at one particular entry, so I'm going to look at the post-drill bedrock model, you can see that the abstract is in there with links to the data, reports and a digital object identifier, which will allow others to cite the data when it's being used. So we've also got, as I go through, we've also got an API platform where we are publishing our data as an API so that other developers can easily tap into it and access the data as it's being collected and displayed on our servers. And we've also got a core image viewer, which I sort of touched on earlier, but I'll give you a bit more of a run through here. So all of the borehole cores they've been extracted, they've been imaged, and you can actually get to have a look at what the ground looks like in high resolution detail, which is great for scientists no matter where they are around the world. They can all get access to this fantastic resource and information. Right, okay, I'm going to hand back to Mike again, so I'm just going to move out of the hot seat and let Mike talk to you a bit more about what we're doing in Glasgow.
That's brilliant. Thanks, Jerry. So just a few more slides now to talk a little bit more about what the Glasgow Geoeng Observatory is about. So this slide illustrates the design concept, and what you can see here are the rock strata underground. You've got coal seams, some of them work, some of them not. You've got collapse zones. All this creates space in the subsurface. Now the water table is typically quite shallow. Maybe a few meters or tens of meters below ground level. And so the whole of this system is saturated with water. And we can drill boreholes into the ground. We can put pumps down and we can pull out the water and re-inject it in different places. And we can start to extract this thermal energy from the ground using the heat pump, as I said earlier. Now, in a commercial or residential application, the heat pump would be taking that thermal energy and using it to heat the homes or the buildings. What we've done in the Glasgow Observatory is swap out that residential heat user for a research centre that has great flexibility in the amount of energy that you can take out. It's able to and also put energy back in. So you can take energy out of the ground, and people are now looking at possibly storing solar energy, for example, that's collected in the summer and putting that back into the ground so that the ground is heated up and it's ready for use in winter again. So you can use the subsurface as a thermal reservoir. So the Glasgow Observatory has been developed so that scientists and engineers have a versatile test bed, if you will, that they can use to bring equipment so they can run different tests. They can check the effect on the water chemistry, the microbiology, the rock, the structure of the mines, all kinds of different things, all the kinds of technical questions that you want to get a handle on if you're investing money in a technology like this. There's a picture there on the right-hand side showing one of these research boreholes going in, and you can see we've got sensor cables, we've got ports for taking the water out of the mines, lots of instrumentation going into this site. So this is an aerial photograph that shows the location of the Glasgow Observatory. And as I say, the inset there shows that it's not very far from the COP26 venue, just outside Glasgow city centre. It's in a loop of the River Clyde called the Cunningar Loop. And there are 5 separate compounds across this area, fulfilling different functions. Some of them have boreholes intersecting different mine workings. Some of them have monitoring wells, which are actually checking the water quality above and below the mine workings and in the superficial sediments, so that we can see what the effect of extracting the heat might be in the surrounding rock. And then we've also got a seismic monitoring borehole just down the road, which can check for any slight motion in the ground that could be caused by extraction of heat from the mine workings. So we've got a lot of instrumentation in this area at the moment. And just to mention that the mines in this area are absolutely typical of those across the central belt of Scotland. We've got all the kind of classic distribution of pillar and stall, open gallery workings and long wall workings. So this is very good for getting, it's a very kind of representative research site, if you will. So this slide illustrates the kinds of work that people would do at the Glasgow Observatory, and it's due for final commissioning in Q1 2022. The above ground pipe work and heat pumps are just going in the next few months. So questions, how much heat can we get out of a given body of ground, a given type of mine working? What's the effect of taking that heat on the surrounding rock volume? How long can we extract that heat before the temperature falls to a level where it's possibly not operationally economic anymore to extract the heat? And something that's already been done as part of the observatory development is to understand how best to actually drill the wells into the ground to make sure we get a good connection to the former mine workings. And a lot of that information is there already on the UK Geos website. On the right-hand side there, you can see some actual data from the Glasgow Observatory. This is a profile in temperature. This is a thermal baseline that we're collecting at the moment. And it's a one-month record using fibre optic distributed temperature sensing, showing the thermal gradient as you go to greater depth in the area. So I think we're probably just about at the end of the time. So just to summarise, the Geoeng Observatories are generating all this fantastic wealth of data, and the digital science lab and all the different informatics tools that Jerry described are being used to share that information and use it to best advantage. Doing a good job on the data management and sharing and communication stimulates research and innovation, encourages more people to come and use the Geoeng Observatory facilities. That creates this virtuous cycle. We get more data from people working at the site. We get better evidence. All that's really valuable for engineers developing new systems and for decision making, for development of policy and regulation. And ultimately, we have confidence to move forward and deploy these thermal technologies on a larger scale and transition the heating and cooling of buildings towards renewable energy sources. So the UK Geoeng Observatories, we're entering into the operational phase now for the observatories, and you can find out a lot more about the Geoeng Observatories on the UK Geos website. You can see there that we've also got a contact email, UK Geos Inquiries. If you've got any questions about the observatories, want to know more what the opportunities are, then please drop us an email. And we're building these for an operational lifetime of 15 years plus, so that we can get a really good handle on the long-term behaviour of the subsurface. So certainly encourage you to look at the website. And as you can imagine, there's been an awful lot of people involved in the development of these facilities. It's a major endeavour, 31 million of capital funding from BEIS. And the people that have been involved are too numerous to mention, but I would like in particular to thank the field staff and contractors who've worked for many weeks all the way through the winter in Glasgow, putting all these subsurface installations in place. Fantastic job. So, and especially, I'd just like to mention Alison Monaghan, who's the science lead for Glasgow, who's done a tremendous job of coordinating all this activity. So thank you.
Thanks both. Wow, this is really powerful, especially when you think about the targets for reducing the gas consumption for heating houses, and you mentioned, is it 600,000 heat pump to be installed in the UK? The thing that I personally love about your presentation about how, or your initiative, is about how you empower others, scientists and practitioners, to access information but the ability to test and play with it, and hopefully come up with some good ideas themselves, or concepts which we probably wouldn't have thought about. So what I'm looking forward, I guess, in future is hearing some of the outcome and tangible solution that came out of the observatories. That would be really, really interesting. But maybe we could do another event on that.
Absolutely.
So thank you both. And thank you also for Jerry for presenting the platform as well. So that was good. Okay, so we're a bit ahead of time, but that's good, because that means more time for questions, and some questions are coming in, so keep bringing them on. And I will now pass on the baton to Gareth Farr, the head of heat and byproduct innovation at the Coal Authority. So Gareth is a hydrogeologist and has extensive experience in ground sources heating schemes, using groundwater and mine water, whether it is in regulation, research, or applied solutions. He's passionate about repurposing our historical legacy of coal mining to help it benefit communities and meet the net zero challenges. So Gareth is going to tell us about the 2-year in making collaboration project between the Coal Authority and BTS, as Mike mentioned earlier, resulting in the provision of maps illustrating British coal mines temperatures, and being basically the first map of its kind in Great Britain. So really interesting. Over to you, Gareth.
Thank you very much. So I can't see my slides here.
No, we haven't got them yet. Are you able to share your screen? Ah, it's coming.
Right, sorry. Let's just F5 that. There we go. Is that the full screen view?
Yeah, perfect. Thank you, Gareth.
Okay, wonderful. So thanks very much for having me, and good afternoon, everyone. My name is Gareth Farr. I'm the Head of Heat and Byproduct Innovation at the Coal Authority, and I'd like to talk about how we hope to turn Britain's coal mining legacy into a low-carbon energy asset for the future. I'll give an overview of a collaborative project that we undertook with the British Geological Survey, but also a high-level overview of the coalfields in Great Britain. And then we'll move on to sort of two short case studies of where this technology is being put into real use as we speak. And hopefully it'll dovetail really nicely with Mike and Jerry's talk that you've just heard before. So who are the Coal Authority? The Coal Authority, a non-departmental government body, and we were created in 1994 by the Coal Industry Act. So we in effect own and manage the vast majority of coal mines in Great Britain, and pretty much all of the subsurface coal mining operations have ceased across Great Britain. And as a result of that, a lot of the dewatering schemes that once kept the mines dry underground have been turned off, and many of the workings are now flooded with water or becoming flooded. The map on the right shows Great Britain, and the brown areas show the extent of of the coalfields, which you can see is significant. And sorry, I should have marked Glasgow on there, but it's obviously right up at the top in Scotland. So we can see it underlies significant areas of Great Britain, and we sort of estimate as well that 25% of homes and businesses are on coalfield areas, which creates an obvious demand for heating as well in these areas. So a little very short summary about what is in fact an incredibly long subject, but the stats are that where we have stats anyway, are that there was 25,000 million tons of coal removed from the coalfields of Great Britain, and there were some 23,000 collieries in operation at various different times. At its peak, the coal mining industry employed 1 million people in the sort of start of the 20th century. So we don't need any more on that to know that it was a significant part of our industrial legacy. And with all large-scale industrial operations as well, there can be a lot of cleanup to do in the future, and as in part why some of the things that the Coal Authority delivers. So associated with closure of underground mines, you often have mine water breakouts, and we've been responsible for constructing 76 mine water treatment schemes across Great Britain that treat mine water that is either pumped or flows freely from abandoned coal mines. We treat 122 billion litres of water every year using these passive or active treatment schemes, and prevent 4,500 tonnes of iron solids entering watercourses. So here we are with our heat demand, and on the right again is a map of Great Britain produced by Bayes recently, and the sort of bright colours there is the colour ramp showing the annual heat demand density for Great Britain, and in white outlining those areas are the extent of the coalfields, and you can see, other than sort of London and the southeast, bar Kent, of course, so there's a small coalfield, a lot of the rest of the country has quite good synergy with where the coalfields are and where the large populations and thus the heat demand occurs. So I'll also introduce the concept here that although the talk is primarily about recovering heat from abandoned coal mines, we can also use the heat pump technology for cooling, and it's possible as well, like Mike suggested as well, that we can use certain areas of coalfields, subsurface coalfields, for interseasonal heat storage in the future. So really, we're trying to repurpose what was once a significant liability into a low carbon energy asset by recovering heat from these flooded workings via heat pumps and heat networks to supply homes and buildings. So you may just have seen this diagram, but it was too good not to use. So all credit to BGS here for this one. So the very simple concept, which I think we've probably got now if you heard the talk before, was that in short, mine water is abstracted from underground workings. And as it's brought to the surface, it's taken through a heat pump where we can extract the heat. And then this heat then can be circulated into homes or businesses for space heating. And usually only a small delta T or change in temperatures is realized across the heat pump, a couple of degrees perhaps. And then the cooler water is then returned to mine workings that are either separated or hydrologically down gradient from the extraction point to avoid any sort of thermal interference. So there's the basic concept. So we can, as I mentioned, a lot of the workings are underground, and this is where a lot of the water is retained within the working. So how do we access these points? Well, we can drill bespoke boreholes, and that can access the mine water in the subsurface, but there may also be existing shafts from some of the many past collieries and operations. However, lots have been refilled or made safe. There's also natural points on the hydrological cycle where water will, under its own accord, come out of the ground. So whether that's been done by a constructed mine drain adit or or just by reaching the low point of the hydrological cycle. There's mine water heat could be harnessed from these sites, but there's also the 76 treatment schemes I mentioned that bring mine water to the surface, and these can potentially be repurposed for heat recovery operations. So below that, the use can be in heat networks, so for multiple houses, but we could also find a use for cooling, and certainly in the UK I feel we're experiencing hotter and longer, warmer summers. So cooling demand may increase, as it might do if you have large data centers or other industry with cooling demands. And of course, like I mentioned, the storage of heat, whether that's from things like incinerators or excess heat from renewable energy projects, could potentially be stored in certain parts of the coal fields. So this is the collaboration that we undertook with the British Geological Survey. So we worked with them under the Geospatial Commission, and we realized that actually, as this sort of topic was building up momentum in Britain, that we really needed some sort of mapping exercise to show what the temperatures were in the subsurface in coal mines. We needed to identify where we had data, where we didn't have data, and perhaps it would be a good first part of a screening tool, at least, for when these schemes were being designed or chosen. On the side as well, of course, gathering all this data together would allow us to improve our scientific knowledge and also to pose new questions on what could drive temperature in coal mines. And we also found that, or we also hypothesized that we could use this as a communication tool with the wider public. So with a group of other organizations, we sit on a body called the Geo6 and the Geospatial Commission, and we use that to facilitate this collaboration. So how did we actually collaborate? Well, we co-developed the project and we shared data, and the graph on the left is a snippet from one coal field where we pooled our data resources with temperature data living at both the British Geological Survey and the Coal Authority. We combined our skills, which were complementary, but in other cases also slightly different. And we decided early on in the project as well that whatever we create, we would have a shared IPR over, and that we would do joint communications. And we hope that this sort of collaborative approach would see an increased impact of the final map that we put out. And we also hoped it would show continued partnerships. And this is the bit where I need to just sneak to the small video, which has annoyingly just slipped out of this presentation. So apologies to everyone watching this at the moment. So if I stop sharing that, and I'll just share this screen. And so our final output that you can see here. So here's Great Britain, and you can see all these various polygons that are being highlighted in a temperature map on the right-hand side. So we mapped the temperature of each of the coal fields at 100-meter slices throughout each of their extents. And we produced this, which was the first temperature mapping exercise for the coal fields, and it was really well received. The temperature data goes from near the surface down to over 1,000 meters, and that was really a great output from our collaborative project. So apologies for that slightly unsmooth transition there from video to so right, here we are. So anyway, we produced those maps and they were really successful, and they've actually allowed us to sort of formulate our collaboration to a much greater extent. So going away from the sort of scientific mapping background of these systems, we've got two case studies that I'd like to just draw your attention to. So both of these case studies that I mentioned are not being led by the Coal Authority, but we're working in partnerships with the bodies that are delivering them. So the first one is a borehole system, as we call it. So it's based in Gateshead in the northeast of England, and it involves drilling of multiple boreholes to about 150 meters depth to abstract water from flooded mine workings. Now, there'll be hopefully about 6 megawatts of heat, I believe, generated from this system. And interestingly, it will supply about 1,250 new homes, care home and a stadium, but it will join onto an existing district heat network, so as a sort of extension to that. So it's a really exciting scheme there in Gateshead, and being led by Gateshead Council, I should say, with various funding from Heat Networks Investment Project and so on. So watch this space, and hopefully early next, or at some point next year, we might get to see it in full commission as well. So case study 2 is another scheme which is in development, and this one varies slightly in that we already have one of our aforementioned mine water treatment schemes at this site. So the picture on the top right shows a mine water treatment scheme which treats significant amounts of water from some flooded workings, and it treats it for the purpose of protecting an overlying drinking water aquifer. However, this water comes out the shaft at about 20 degrees, and is continually pumped and treated. So it made an ideal location to co-develop a new housing development, which the outline of which is in the bottom right-hand corner. So again, this is led with Durham County Council and Tolent Construction, and then we're providing advice and facilitating the licenses and things that will allow them to take the heat. So the scheme hasn't broken ground yet, but the heat resource is there, and we do hope that in the very near future this is realised, because this would be the first new build housing estate that was heated by mine water in the country. So exciting times to watch. So in summary, although we haven't quantified it precisely, we do believe mine water could be a significant low carbon heating and cooling resource for Great Britain. And there's 2 district heating schemes in development, but also there's a handful of other schemes that are in various stages of earlier feasibility. But overall, the collaboration with the British Geological Survey under the Geospatial 6 group has been really beneficial to create the first temperature maps of the British coalfields, and hopefully the take-homes really were that the partnership working has been really, really powerful, not only to increase our impact, but also to share knowledge between what are quite complementary government bodies. And also we hope to hit our UN Sustainable Development Goals, which are shown on the right, and other sort of UK and local policy and government targets to reach net zero. So thank you very much for your time.
Thank you, Gareth. Really insightful, and for someone who doesn't know anything about mining, it's really inspiring to see how mine waters can actually be reused in clean heating resources and solve the climate crisis. Also, what was great as well is to see how beneficial it was for both the organisation, the Coal Authority and BGS, working together through this innovation approach to innovation, and how effectively what you said is about that increased impact, like more reach, more kudos, because the fact that you're 2 organizations doing it together. So that sums up our presentations, which now we can move on to our panel discussion. So I will invite all the speakers to come back with their screen, with their video on and their microphone on, so we can all have that very insightful discussion. reminding also all the audience to keep asking questions, and as we wait for more questions to come in, I will, yes, we can see Jerry, it'd be good to see Jerry a little bit. So yeah, so I will kick off on one question for all of you, and because of my international role and always looking at what's going on around the world geospatially, I guess you know what you presented today is all different approaches, different kind of topics and applications, but similar, you know, using geospatial data, and all really groundbreaking. And I was just wondering whether you were aware of other nations that are undertaking similar projects or similar approaches, and whether that inspired you in terms of doing those, or whether it's the opposite. Are they inspired by you, or have you had some kind of contact? So just to kick off, I don't know who wants to start.
I'm happy to start.
Okay,
I'm happy to start, Olive.
Juliet, go on.
Yeah, I'm happy to start. Thanks, Olive. Yeah, the interesting thing about this is, I don't want to get too technical, but artificial intelligence and machine learning has been really quite large and huge with tech. And we decided to turn everything on its head during this period and during the pandemic and start looking at problem statements with different countries that had approached us. And it was really nice to see very quickly that our tech could be adapted to actually address their problem statements. And as a consequence of that, quite a few of the developing nations are now interested in increasing their speed to get up to date with their geospatial maturity to address the issues that they have by utilizing our tech. So it's really nice to start with a problem statement and then have the tech deal with the problem statement at the time. So we now have different countries that we're working with. Rwanda, Mozambique, Ethiopia, etc., have been very interested in this tech and deploying it.
That's great. What about the others? Obviously, from a different angle, any lesson learned from abroad or interest from others?
I can speak.
Mike, I think you were going to start. Sorry. Yeah.
Yeah. So there is this great potential of using thermal energy in the subsurface for space heating, and so it is an active area of research, you know, in many countries. And but it's a big topic. There are all kinds of questions on the regional, on the small scale, on the every country has its own particular geology that it has to work with and particular opportunities. You know, for example, Gareth was talking about all the coal mine resource that's available in the UK. So there are theoretical questions that need to be answered, and I would say that the UK GEOS facilities are very much around understanding the fight, you know, the detail around what exactly is going on when you're transferring the heat from the former mine workings. We've got a lot of monitoring capability that's going in the ground so that we can profile not only the thermal transfers but also the effects on the rock mass, the water quality, the microbiology. It's a very kind of very holistic kind of package. But other countries are working on other aspects, you know, much bigger systems, deeper systems. Yeah, there are many different angles to the technology.
So a lot to learn from each other, basically.
Yeah, I'll second that as well. I'll second that as well, and say that, you know, we've also had really good response from friends in other countries, such as in Herleen in the Netherlands, where they have a large mine water heating scheme there, where they've been very willing to share information with us while we've started on our journey. So hopefully as we pick up speed, we can reciprocate those data sharings as well, which will be a lovely thing to do.
Yeah. And James?
Yeah, I think so. Obviously, CEWA 2030 is an international collaboration anyway. So I think it's really interesting to see how countries and actually a lot of private organisations have been throwing their weight behind that. I think that the bit where it gets interesting is in the high seas, where there's no national jurisdiction, there's no hydrography programs for national use. And I've got here a segment from my map, which, if you can see that, that is the southwest tip of Australia. And basically this bit here represents the data gathered during the search for MH370, which is probably one of the biggest international survey collaborations that's ever taken place. And what I'd like to see is more of that sort of collaboration, though obviously not the reason for it. But again, it's once you get out of national waters into the high seas, it really is a collaborative activity, a benevolent activity, and really how do we get people behind that?
Very interesting. So I got a couple of questions, but I'll start one on a very technical one, which actually applies to all of you. So again, we'll go around, and then there'll be some specific questions for each of you. But in terms of obviously, you know, your presentation all about the aim to put out that data out there and to enable the users to make decisions. And it could be so varied, but how do you ensure that your data is fit for purpose and enables the, you know, the end user? So it's more of the end user kind of perspective, how it enables them to take that, to get that information to make the right decisions. So I guess I'll go through the same order, if that makes sense. Juliet first.
Sure. That's a great question, actually, Olive. And I think a large part of our collaborative working is a discovery stage. It's really pulling together all the stakeholders. Even though one ministry or one department might come to us, we help them to pull all the stakeholders together to understand what the key areas they need to work in, what prioritize their problem statement, so they have a way of growing and developing what they need, and then we deploy, and then we develop them as well. I think it was it James or Michael, I can't remember, that had that lovely picture of capacity development that they were doing, and that resonates with us. We very much develop the capacity so that they can utilize the data, and then we keep the relationship very open. So even though we finish the project with them, there is an open discussion to ensure that the data is still very much fit for purpose. They're able to develop on what we've delivered, and they're able to also get the results that they want.
Great. Then I'll go around the screen again. Oh, but James, if you want to go first, go for it.
Yes, right. Okay. So we've just kicked off part of a project with the Open Geospatial Consortium, looking at how we can get hydrographic data that's been gathered for very specific uses. It sits in a standard that has been developed for navigational purposes primarily, and we're trying to develop that standard, the new set of standards that will allow that data to be more interoperable. And so we've just, alongside the Ordnance survey, we've now elevated our status with the OGC to strategic membership. And what that allows us to do is actually kick off projects where we can really look into how to make that data more interoperable and reusable, and get it out of that hydrographic bubble and available to people who are trying to do wider use of it. Because I think using geographic data is there's elements of it which is hard, it's complicated. Things that people overlook, things like metadata management, what makes good quality measurements, things like that. Really, it requires a lot of stuff. And again, the reason I showed that slide on capacity building is because this isn't a UK activity. This is a global activity.
Yeah, great. And I've just lost my train of thought, because you were just saying something, I'm thinking of something, and then now it's all gone. So I'll pass the mic and Jerry, and then I'll probably think about it again. But it's just getting old, I think.
Yeah, I think it's a really, really good question, and that sort of a question is at the BGS that we've struggled with historically. A lot of the information and the data that we've collected in the past has been associated with a specific science project, and our scientists have, again, in the past, been quite nervous about other people using that data, but maybe not in the intention that they had in mind when it was collected. So we've certainly gone through a bit of a process at BGS over the last sort of 10 or so years around sort of relaxing a bit and trusting other people to use our data and use it well. And we've been in quite a fortunate position with UK Geos, because we've been able to start from almost a blank piece of paper when we're collecting the data, to be making sure that we capture as much metadata associated with it as possible, and to publish it and to make it all accessible, you know, as soon as we can, and make as much of it available. So not just the data, it's all the metadata around it, and all of the reports and the associated information. So yeah, it is a really good question. I think metadata is the key, and I think, you know, So we've certainly learned to relax and just trust other people to make some really good judgments and do some really good science with data that wasn't originally theirs to begin with. We're starting to see some really, really interesting results.
And Gareth, now I remember what I was going to say, but I'll leave Gareth to speak first. I'll see you at the end.
Yeah, so I think we've, you know, the thing I may not have made clear in my talk as well, that of course the temperature maps that I briefly showed as well were all open access as well, and that's really allowed us to engage with our stakeholders as well through the open access data platform, and then feedback from those stakeholders hopefully will allow us to co-develop whatever comes next within that infrastructure that we need to better plan mine energy schemes.
Yeah, and what I was going to say, but actually it kind of fits with what you've just said, Gareth, is about opening up the data, so making it accessible, but actually not to just those people that we used to know or we know are using it generally, because by opening up, it opens up the end user. You don't know who else is going to use it, and bringing back to the quality and what you're saying about the metadata, by making sure people have got the confidence that they're using a data that is actually useful and is going to help them, and it's the right information, authoritative information. So so that's really, really good that you have those kind of network.
Yeah, and quite often, Oliver, tapping into what you're saying there is quite often, if it's a single data set on a single piece of science or research, then it's incredibly important that it's right and it's accurate. But if it's one of maybe 10 or 20 data sets, just being there to be able to validate what the other data set said is good enough. So we do need to relax a little bit and just try and publish as much as we possibly can.
That's a very good, good point. So I'm going to pick a few questions from the audience, and not in particular order, but there is a question for Juliet, and you touched upon it on the first question about international. And the question is, if it's possible to produce detailed mapping for informal settlements quickly and cheaply, what are the barriers stopping developing countries from doing this now?
Great question. We have a lot of developing countries obviously interested because we touched on this. The biggest barrier is funding, to the extent that we actually have an offer at the moment that we've offered into Africa, where we're happy to develop matched value add for anything that they bring to the project. So we're able to deliver the discovery, we're able to deliver things, and they still don't have enough backing or enough understanding or gravitas within the organizations or within the government to be able to vocalize what they need and understand and deliver them the actual message about how geospatial data can unlock other things and help them with sustainable development goals and help them with the COP26 goals. So what we've been doing is trying to work with them to get through the different government areas and get access to funding. But the biggest barrier for the developing countries is definitely funding.
So is funding linked to capability as well, or is it just totally just purely funding?
That's a really, really good question, because what you tend to find is there is a bit of castle capability and capacity development that we need to do with them. So there is two levels to that. So there is the initial funding, and then there's the training to develop the capacity and the capability as well. But they have the interest. We know the value that geospatial data and location can bring, and it is a struggle to actually help them to unlock the funding to help their nations.
Thank you, Juliet.
Thank you very much.
I've got another question, unless anyone else wants to add to that from their perspective. I'll go to the next question. Okay, so a question for Mike and Jerry. Has there been extensive research around the impact on potential ground movement as a result of pumping high pressure water through the subsurface? Very technical question.
Water is circulated through the subsurface for many different reasons, not least of which extracting groundwater for drinking. So there's a very well understood science around the transport or flow of water in the ground, and engineers are well versed in how to control the pressure regime so that you don't induce deformation or fracturing or movement of unconsolidated ground or whatever else it may be. So in terms of the use of water as the medium to extract heat, that's not kind of a new area itself. I guess the understanding that the Geoeng Observatories is about is the effect on the chemistry of the water, the microbiology, how much heat you can extract from a given rock type, dependent on its porosity, conductivity, how it relates to all the other rocks that are around it. Those are the questions that we're really addressing, and the circulation of the water is relatively well understood.
So not too much risk of an earthquake or something being reached by that. That's good. Now I've got a question, probably more for James, if that's okay. It's about the technology, because you kind of mentioned quite a lot of like a breadth of technology that the Hydrographic office is using, you know, from remote sensing, Earth observation, machine learning, the UAVs going around. And I guess it's about how, so it's great to kind of harvest all this technological or tools basically and techniques, but how does those capabilities are supporting policy implementation, especially when it's international waters like this?
Yeah, really good question. And I think that comes down to, so elements of this come down to that sort of question of sea blindness that I talked about, and how much do people understand about the link between good quality foundation data and the application of it to some of the key policy questions that we're facing as a country. And that's not just for climate change, that's for transportation, it's for defense, it's for other uses of the marine resource. So at the moment, one of the big things that people are concerned about is deep water mining. And so as we try and move towards more environmentally friendly transport, like electronic vehicles, where do the minerals for that come from? And I think actually, one of the questions is, one of the answers to your questions is it doesn't. So actually it's very hard to link some of the policy decisions in around the world to actually a good understanding of seabed mapping and what's going on there. So I think that's really, my key message is, how do we understand what the impact of our policy decisions are if we've not measured the environment that it's taking place in?
Okay, I hope that answers the question for the person who's posted it. I've got a question for Gareth. This is probably more my question, but it's about collaboration, because you talked, your example, everybody talked about collaboration, but your examples was a specific collaboration with BGS. And I guess it would be like, what would be your advice for others in terms of working collaboratively and making it successful in a way? Because you've gone through it, you've probably learned some lesson or kind of seen how or what worked well.
Yeah, well, I should admit to something first, and that's that when this project started, I was actually a BGS employee, and now I'm a coal authority employee. However, that doesn't really matter so much. But what I think the key things really are, you have to we had quite a few pre-meetings with people just to generally make sure that we were all singing from the same song sheet as well, and that actually we could get along person to person. So that was quite valuable before we rushed into collaboration with people we didn't know. And we also spent some time on a collaborative agreement just to get the rules of engagement down beforehand. So it meant that when the project got to its end, someone didn't say, oh, no, it wasn't going to be that way. So we had quite a clear agreed rules of engagement, which was, I think, did see us through quite well. And all the other standard stuff, you have frequent meetings and so on and so forth, but really those things sort of set us in a good stead. And I think perhaps the sort of, what we both wanted to achieve from it was probably aligned as well, I think, in terms of our organizational goals.
A bit like what Talia was saying about, having those common goals, but also aligning to new, like global, joint goals as well.
Exactly.
Great. I've got a question for Mike again from the audience. How far do you think we can go with extracting heat from the ground? For example, can we use the knowledge you're gathering to support other countries around the world? Just a bit linked to maybe the first one.
Yeah, absolutely. As we mentioned, we're very keen to make all the data that we're gathering from the UK Geoeng Observatories open access so that others can benefit from the understanding that we're gaining. There's an awful lot of information already available on the UK GEOS website. And likewise, a lot of other countries are publishing, really interesting studies on all kinds of different thermal systems, and obviously we can benefit from that. So there's certainly a lot of information exchange going on. And in terms of how far you can go from extracting heat from the ground, it's worth coming back to something that we pointed out, Gareth pointed out earlier, in that you can actually recharge the subsurface with thermal energy in the summer. If you design the system so that you can harvest solar energy and then circulate that warmer water back into the ground, you can recharge it so that you've got that heat there ready to use in winter. And even better than that, if the geology is right, and Gareth made an important point that you need to have a kind of a closed volume to be able to do it efficiently, you can take excess heat energy from buildings in summer and cool the buildings, which is also an important requirement. Store that energy for the winter. So if you operate it in that way, then it's renewable. Yeah.
So is there some lesson learned for like those countries that are suffering the heat waves at the moment that we're talking about, about cooling the buildings?
It very much depends on the local circumstances, of course, and what kind of geology they have and what depth the water table's at, and many local factors. But certainly, if the economics and the ground conditions support the installation of one of these systems, then certainly they could benefit from that. Yeah.
So anyone out there who wants to speak to Mike about that kind of stuff, please get in touch. Right, so I've got a question to the Geospatial Commission from the audience. Talia had to leave because she has other commitments, but I guess I'm here, so I'll try to answer it, which wasn't the plan actually. But so the question for the Geospatial Commission is about post-pandemic, how does the Commission aim to keep location data a priority for government? And I guess the answer from our point of view is that we're just here to continue promoting the value of geospatial data. So explaining the power of location data is relevant to everyone. And we just keep on talking to the government about how each relevant priorities at the time where geospatial data can actually help towards these priorities. So at the moment, we're all talking about climate, and this is a good example of this. We talk about how we can help climate action, but there's so many different priorities. So it's about talking to the right people. But we have a strong mandate being in the heart of government, and we'll just carry on leveraging that position to broaden the awareness and the appeal of location data. And we'll harness partner voices like we're doing today, where the strength of feeling and evidence of good use is apparent. So this is our role, is to carry on promoting the great work that's been done around, and yeah, we have the network for people to listen, hopefully. So that's the key. Going back to a all panel question now, and we still have a bit of time, so hopefully there'll be more questions coming in because I'm running out of questions. But what I'd like to ask you is I guess, what's next? So, you've all been working on different projects, innovative applications of geospatial data, but we kind of want to know more now. It's like, what else is going to come from the organizations? So are there any exciting projects in the pipeline within your own organization that we need to keep an eye out for? So again, I'll start with Juliet, only because you're first on my screen.
Yes, I think with COP26 and us adapting and reacting as well to reducing the effects of climate change. The exciting news that we've got hot off the press is that the Ordnance Survey will be working with the UK Space Agency on a heat data project, which we did announce at COP26, and we'll be testing ways of how to use EO data, Earth observation data, climate data, accessible to non-specialist users to support adaptation and resilience internationally. So the data will be open and free, so we're ensuring that we're using the FAIR principles, and look out for us to announce a bit more information on that. So that's the next step for us at Ordnance Survey. It's the next big exciting project we'll be working on.
That's great news.
Mm-hmm.
James?
Yeah, so we've got some interesting work going on at the moment, looking into how we work with quite an exciting company called Saildrone, who are doing some work in the Cayman Islands to map the entirety of the Cayman Islands using some very sort of low impact autonomous vessels. So that's really exciting, and we're hoping to see data coming through from that. We're also doing some collaborative work through the United Nations Committee of Experts on Global Geospatial Information Management. They have a integrated geospatial information framework, which is basically a way for implementing sort of spatial data infrastructures for countries that want to do that. And we are working with them on something that's called the IGIF Hydro, which is about how we can put together, basically for countries that have not only ocean, coastline, that sort of thing, but also riverine transportation, Great Lakes, that sort of thing. How can you manage geospatial data, and what are the steps you need to put into place with that?
Sounds exciting too. Okay, more to come. What about you in BGS, Mike and Jerry?
I can mention a project that's in the consultation phase at the moment, called COSLab, and what this is a subsurface research facility that would look at instrumenting a CO2 injection well for carbon capture and storage, and it would a similar kind of theme to UK GEOS for thermal energy storage, but it would, answer some of the questions around the behaviour of the subsurface in response to carbon dioxide injection into reservoir structures. And obviously, carbon capture storage is something that's very actively being investigated at the moment, and this would generate data and provide a research facility for researchers in the UK, working, perhaps in the UK offshore. So there's another whole team at BGS who are engaged in the consultation on that.
Great. What about you, Gareth? Any exciting stuff from the Coal Authority?
Yeah, well, I think our sort of exciting stuff on the horizon is sort of our R&D project within my team, where in short, we want to see how multiple mine energy schemes interact when they're built in the real environment. So it will be quite an applied R&D project, ultimately to underpin better, more sustainable licensing for these schemes. So that's in development now. So watch this space. And of course, as always, open to collaborations or ideas. So you know where I am.
I second that too. I think we should, as I was watching the presentations, I saw a lot of things that resonated with things that we're working on abroad. So completely open to collaboration with others here.
And I was going to say, already we had two of the Geo6 working together, BGS and Coal Authority, maybe because it is about subsurface data, but actually how it might be a good thing to start thinking about how we can all work together to have the whole biosphere, land, water or marine and subsurface together, and see what we can do.
In fact, we must get in touch, because I would love to work with the OS on the above ground elements that relate to the coal fields as well. So I know now is not the time on a big public forum, but,
We'll
but just to shore that up, that these are possible collaborations.
Absolutely, thank
you. And even though these were like final questions, we do have another question actually that just popped up. So, and as we've got time, we can take it. So as public sector bodies, and that's for all of you, can you say something about the public-private partnerships that you're working on to support the climate agenda? Actually, public-private partnership is something that is coming back more and more, and I know the US is definitely looking into this to kind of bring capability up for governments. So have you got any response to this? Who wants to start? Have a think.
I think, yeah,
I think it's about working with, sorry,
yeah,
go on.
So at BGS, we partner with and collaborate with all sorts of different people across industry, academia, and other parts of government. And I think we're very keen just to pick the best partner, the most appropriate partner, the partner that has the skills and the expertise that we don't have, and therefore makes that piece of research even stronger. So I think private and public partnerships are very, very important. And of course, we all operate within sort of the government guidelines and the published guidelines around how we should interact with these organisations and share the results of the works that we have. So I think it's a very important part of the future, and I think the way that it's set up can work very, very well.
Absolutely, and I second that as well, Jerry. And to that extent, OS are actually looking at more collaborative things, looking at green finance in particular, where we're working with the private sector as well. So I think it's almost fit for purpose partners, isn't it? You have to make sure that you get the right capability to suit the problem statement that we're actually looking for a solution to.
Gareth, did you have any comments on that?
Yeah, no, I'd just second all those comments, really. You know, it can be really valuable working with the private sector. And as long as we engage on the terms that are set out to us as government bodies, then it can be really, really fruitful because they offer things that we can't offer and vice versa. So, and, you know, also joining forces is the only way we're going to reach our net zero goals, isn't it? You know, it's teamwork across the board.
Definitely. And James, have you got any closing remarks on this?
Yeah, I think public-private partnership sort of, it means quite, there's a narrow definition of that in many respects. So I think what I would say is we work with industry organisations, like I mentioned on sail drones. So we talk to people who are effectively customers of our data, so we can understand what they're trying to do with it, or people who are gathering data that we then might make use of. So it's a collaborative arrangement, but it's not what we would call a formal partnership. So basically, doing work with industry so that we understand either what they need or what they provide to basically solve these problems that we're trying to address.
Thank you. So now we've run out of questions. I will kind of close up the session. But before we part, I just wanted to first of all thank all the speakers today, so Talia and every single one of you for your amazing contribution and amazing showcase, and sharing with us your ambitious projects. I also would like to thank the whole KTN team for putting together this incredible platform and set of events and providing us the opportunity to share those great examples. And obviously thank the audience for joining us today and asking some great questions. I need to remind the audience that you can you have the opportunity to network in the Space and Geospatial Virtual Pavilion platform, and also please make sure that you visit each of the speakers' organization and the Geospatial Commission exhibitors information page, so you can find everybody's details and the website, and we will share further links as well in the output document. What I wanted to say as well is to wrap up is that obviously as the Geospatial Commission, we've been delighted to be part of the COP26, both in person in Glasgow. We had Talia and an event on Tuesday, and obviously part of this pavilion. And the reason we do this and the reason we're delighted is because we do believe geospatial data is integral to solve climate challenges. We know it and we want to shout about it. And over the last 2 weeks, of COP negotiation. We've heard that, you know, the renewed country pledges could limit the global temperature to 1.8 degrees, which is great, but it's still 0.3 degrees more than the original target. And sadly, we heard as well that analysis on global carbon emission is now showing that the emissions are going back to record levels as just before the pandemic, which is, you know, obviously going to be a challenge to curb that. So it's, what I want to say is it's upon all of us really to show that we can do it, and we can do it in different ways, like shown today, and we can help achieve those targets, and we can help like with climate adaptation and mitigation. And we need to shout about it, we need to promote it, to make sure that everybody's aware, so they have the opportunity to use the data that we provide to solve these problems. And so, and as you all said today, the importance of partnership and collaboration, we need to continue to form this partnership and collaborate with others to make it work effectively, because we have no choice. We have to, for the sake of our planet and our future generations. So please share the word, share this recording, you know, the people in the audience and yourselves, the speakers. And for people who want to approach us, come to talk to us, let's work together. And yeah, it's about teamwork, and we can do it. So thank you, all of you, for joining us today. And on this note, I will leave you with 9 minutes spare, so you can have a nice cup of tea or whatever beverage that you like. So thank you all again.
Thank you very much, Olive.
Thank you.
Thank you.